thanks, Alex, and I would like to thank the hub for giving me the opportunity to communicate on my subject. So at the University of Edinburgh, we have been building an automated fiber tapeline, but it's quite peculiar. It's working with powder epoxy. So in this presentation, I will first speak about why we have been using this powder epoxy technology. Then I will describe the tapeline and follow through with the applications we have been targeting thus far. So first, why would we use this powder epoxy technology? Well, if you have a look here on the differential scanning calorimetry graph, you can actually see that there's a small endothermic reaction showing the sintering and melting of the powder, followed by 100 degrees where nothing happens, and then the cure here. So what it means is the materials, once melted, is completely stable at ambient temperature. It's heat activated. So that's the first thing. It doesn't need any refrigeration or storage. So the second asset is the low mechanical viscosity. So as you can see here on the parallel plate rheometry, as the temperature is increasing, you can see the viscosity decrease before gelling. So basically, the viscosity you get is extremely low in comparison to thermoplastic. So that's basically the best of both worlds, because it's not curing at ambient temperature. It's completely stays stable, and it has a low minimal viscosity. And when you think about it, if you can separate the melt and the cure, what you can also do is one-shot cure and co-cure different parts. And that's becoming extremely interesting, especially when we are thinking about preforms, right? So two other advantages of this powder is, first, you have a very low curing exotherm. So it's about a third of a standard epoxy system. And when we are working with the thick sections, it allows you for much lesser risks of thermal runaways, and it translates into a much quicker manufacturing. So if you're a wind turbine blade manufacturer, that might be of a huge interest to you. And the second thing is the fact that the powder is a semi-toughened material. It has 3 times the standard fracture toughness for standard epoxy, and thus resists much better to impact and fatigue in general. And all these are actually leading to substantial processing cost reduction. So the history of the tapeline has been taken along 4 to 5 years. So it's coming from a European project called Marine Camp, and in which we built the original tapeline, as you can see on the upper photo here, and that was basically a proof of concept to where we already had a lot of good ideas, such as using an electrostatic powder gun and a Joule heating system in order to create tape. But by then we had little control on tension, temperature, speed. So that's why we've been working with the hub into very much updating this what I would call toy to something that what I would call tool. You know, very much bringing up the technology readiness level and create a real industrially ready prototype. And we have very much gained the ability to measure all the data we are putting in and control the key variables such as temperature, tension, and speed. We can control all these via a human-machine interface. And one of the very good thing with the powder epoxy is we can go much quicker than with a standard liquid resin, and we can go at least to 30 to 40 meters per minute as a comparison to 6 to 8 for a standard system. So that should also very much promote the powder epoxy system. So if we have a look at it point by point, so we can actually see that at the top left bottom, we have a magnetic brake with which we are controlling the tension. We have a speed sensor there as well. We have a tension system which is linked with a magnetic particle brake to keep the tension control. We then have the powder deposition box in which we are putting the fibers are being coated with positively charged powder particles in a dust, a cloud or mist. We then have a Joule heating system to melt the powder, which is extremely efficient and require very little powder. It uses the self-heating Joule effect intrinsic capabilities of the carbon fiber epoxies. And then we also have a collection reel at the end with a linear tape distribution to make sure that the tape is well distributed. So here's the video I should have. So I guess maybe it's elsewhere. Yes, there we go. So explaining the powder tapeline with the speed. So yeah, just a quick video to promote the tapeline. So as for now, you won't see any powder being coated. We just want to make sure we control everything before we start with the powder coating, but it should come within 2 weeks now. We are quite confident in the tape line possibilities. So yes, here is the infrared heating with the 3 infrared sensors and 5 navy rewinding system. And here is the human machine interface. It's inbuilt LabVIEW system. I'll be happy to show you more once it will be completed now very soon. Right. So if we can come back to my slides. Thanks. Okay, so Now for the last part on the applications, I'm going to show you two, although I've got other ideas. So the first one is concerning automated fiber placement. So for that, I'm working directly with Coriolis Composite, and so what are very much the advantages of a powder epoxy system? So you don't have any stick behavior. So you can see this blue PTFE tape here. Well, you don't need that with our system, as the tape is not tacky at all. There's no partial cure. So you got much better interplays properties, as it co-cures 100%. There's no VOC emission, another very good point, as the fibers are kept under a glassy material. The melted powder then comes back and is in a glassy state. We keep the fibers always under tension, so we've got a better alignment. So that's the one-shot cure processing abilities, and also a potential ability to streamline the top rigging and the automated fiber processes. And one last slide as a transition to my colleague Dongmin. We also have been working on a feasibility study in which we've been toe rigging small toes, so 1K carbon fiber toes, and we've been able to 3D print them on using a 3D printing machine. But I'm sure Dongmin will speak much better than this to you. So yes, I thank you for attending. I want to stress that I believe this technology has a lot of potentials when it comes to applications, and I also believe there's a lot of potential synergy with the works that have just been presented by Dr. Tom Turner and Dr. Eric Kim, and I'll be happy to provide them with tape when I'll be happy with the quality of my tape. So thank you very much, and I'll be happy to answer your question. Thank you.